Here, J.W. Gibbs. He is an American physicist. Derived the equation. They established between the number of phases and number of freedoms and also number of common. That is fixed Gibbs phase rule. F equal to C minus P plus 2, whereas P means number of phases, F means degree of freedom, C means number of components. Next, phase diagrams. Phase diagrams is a graphical representation of phases. In this system, various temperature, pressures, and composition. It is also constructed by equilibrium condition depending on the number of components. That phase diagram it is unary component and binary component, tertiary components. The classification of equilibrium diagrams, that is amorphous phase diagram, eutectic phase diagram, eutectoid phase diagram, periodic phase diagram, peritectoid phase. First one is amorphous system. When the two metals are completely soluble in the liquid and solid state, the resultant phase diagram is also known as binary amorphous phase diagram. In this example, the copper, nickel, aluminum, magnesium, that are the critical structures except the chemical composition of the components. This is a phase diagram for primary amorphous system, copper nickel system. That's the temperature x-axis, that composition weight, and y-axis temperature. The composition ranges between the weight percentage, the alpha plus L. The liquid state should be 1455 degrees Celsius, and the horizontal extremely 100, where the weight should be for the neck copper. The composition is elaborately seen. You can see this: the liquid lines and solid lines should be the peak low to high range. The three different phases appears on the diagram. They are solid, alpha solid region, liquid region, and two phase region. Interpretation of the phase diagram shows that homogeneous liquid solution and alpha phase will be substitutional solid solution at a temperature below 1085 degree. Copper and nickel mutually soluble. Then FCC should be identified as the radius and fact for both copper and nickel atoms. The copper nickel system is a terms for amorphous because of this complete liquid soluble of two components. The line should be separate for the all temperature composition in this phase, that is alpha and alpha plus region below the solid phase. Solidus and liquidus line intersect the two composition of extremities to melting temperature of pure components. For example, melting point of copper should be 1855 degrees Celsius and nickel should be 1453. While heating the pure copper, it remains solid while until the melting temperature is. Next one is cathodic phase diagram. In this system, the each element should be soluble in this other element should be saturation point. Two metals A and B are not completely soluble through all range of composition, and second phase will be form grain boundaries known as cathodic system, that is copper and aluminum system. A binary system, that is the x-axis the temperature and y-axis the composition. In this the alpha plus L will be the center point of the midpoint. It is cathodic composition. Interpretation of cathodic alloy system. Here are six regions: liquid phase, alpha solid solution phase, beta solid solution phase, alpha solid plus liquid phase, beta solid plus liquid phase, alpha plus beta solid solution phase. This is the formula for return as the liquid is summation of solution for cooling that should be reacted with acidic temperature, that is alpha solid solution plus beta solid solution. The acidic phase, the similarity of that acidic system, it is isothermal reversible reaction in which the solid phase transform to solid phase upon on cooling. That is, solid 1 will be cooling are equal to heating with solid 2 plus solid. Next one, periodic phase diagram. In this reaction, upcoming solution are cooling with solid phase and liquid phase transform isothermally and reversibly into solid phase having different composition. It has been written as solid plus liquid. One is reaction with heating and cooling. It will give only solid solution. And peroxide phase reaction. This is same for two solid phase transforms and three solid phase upon cooling. That's the reaction is written as solid 1 plus solid 2 is reaction with heating and cooling. It will give solid 3, that is upon otherwise known as upside down. That's all. Thank you.